Okay, this is your concept number 8, which is classifying, adding, and subtracting polynomials. Okay, so we start out looking at just classifying them. When we classify them, we're basing that off of the number of terms that they have. Now, terms in a polynomials, they're values that are separated by either addition or subtraction signs. So if I have something that's just a 2x, there is nothing else here that is being separated by addition or subtraction signs. So this is considered a monomial. This 2x is considered one term. 2x is considered one term because that 2 and x are being multiplied together. They're not being added or subtracted. So they count together as one single term, which is a monomial. Then if I have something like 2x plus 3y, okay, these two pieces are being held together by this addition, so there are two terms there. So it's called a binomial when there are two. Okay, a trinomial, 3 terms. So I have a 2x squared plus a 3x plus a 5. So again, these three pieces are being held together by this addition. Since there are 3 terms, it's considered a trinomial. 4 terms is considered just a polynomial. Okay, if there's more than 3 terms, you just call it a polynomial. We don't have a special name for it after that. Okay, so just monomial for 1 term, binomial for 2, trinomial for 3. After that, it's just called a polynomial. Now, a couple other vocab, like terms. We've dealt with like terms before. Like terms have the same variable and the same exponent. So those both have to be the same for them to be considered like terms. When you're adding and subtracting these like terms, remember that you are only adding or subtracting the coefficients. The variable and the exponent portion of it stays exactly the same. So we're only adding the coefficient, which is the number out front of the variable. Okay, the whole number, or the fraction technically, that is out front of the variable. So let's look at adding polynomials. When you have 2 sets of polynomials that are being added together, you can just remove the parentheses and completely rewrite it without those parentheses. Then you're going to go through and you're going to combine like terms, just like we've dealt with before. Okay? Be careful to watch the signs that are in the front of each of the term. Okay? It's very important what sign is in front of the term. That's the one that's connected to it. Okay? Then, as just a side note, your answers, your final answers should always be in standard form. Okay? Standard form means that you are starting with the highest power, the highest exponent, and decreasing as you write it. Okay? So you're starting with the highest exponent there is, and you are getting smaller and smaller as you go. So if we look at these first examples, I have a 12m squared plus 4. That's all one polynomial. So it's a binomial because there's 2 terms. So I'm taking this binomial that's in parentheses and I'm adding this binomial. Okay, again, I have 2 terms here. So I'm taking a binomial plus a binomial. Because it's addition in between these 2 binomials, I can simply drop out the parentheses and just rewrite it. Once I do that, then I'm just going to combine like terms. So I always want to start with the highest power. The highest power that we have here is this m squared. So I'm going to combine those like terms first. So I have a positive 12m squared plus, because I'm using the sign in front of the number, so positive 12m squared plus 8m squared. So remember, you're just adding the coefficients together. It's going to stay in m squared. So 12 plus 8 gives you 20m squared. Then I do the same thing with my whole numbers or my constants. I have a positive 4 and I'm adding 5. So 4 plus 5 is 9. So your final answer is 20m squared plus 9. And then I have a trinomial and I'm adding a trinomial. Okay, 3 terms plus these 3 terms. Because it's addition in between, you can drop out those parentheses and just rewrite it. Then you're going to combine like terms. Okay, again, we're going to start with the highest exponent that you see. So in this case, our highest exponent here is this 2s to the 3rd power. So I start with that. I don't have any like terms for that. There's nothing else that is an s to the 3rd power, because remember, the variable has to match and the exponent has to match then for them to be considered like terms. So because it doesn't have a like term, I just rewrite it as part of my answer. Then I go to my next lowest exponent. 6s squared. Right? Again, I don't have any like terms for this either, so it just becomes part of our answer. So far I have 2s to the third power plus 6s to the second power. Now I continue to combine like terms. My next lowest exponent, or the s to the first powers, I have a positive 3s, because again I'm using the sign in front of it, minus 6s. So 3 minus 6 is a negative 3. And then the s just stays. Remember, the variable stays the same. I'm just combining the coefficients together. Then their constants at the end, I have a positive 7 and a negative 4. So 7 minus 4 is a positive 3. Okay. Again, both of these are in standard form. They're starting with the highest exponent and decreasing as they go. Now, in this first example here, I have a 5 times this trinomial plus 3 times that trinomial. So what you have to do first, because I have a number outside of those parentheses, we're going to have to distribute this 5 into this set of parentheses because that's what it's attached to, and then distribute this positive 3 to this second set of parentheses, again, because that's what it is attached to. So when you do that, 5 times 2x squared is a 10x squared. 5 times a negative 3x is a negative 15x. 5 times a positive 10 is a positive 50. Then distribute this positive 3 in. So positive 3 times 3x squared is a positive 9x squared. So you can see I dropped the parentheses here now that I distributed. Then 3 times this 2x is a positive 6x. And then 3 times the negative 10 is a negative 30. So just be very careful. Make sure that you are paying attention to the signs that are there. So positive 3 times a negative 10 is a negative 30. Now you're going to combine like terms just like normal. So we start with our squared terms because that's our highest exponent. My like terms are this 10x squared plus 9x squared, which is 19x squared. Then my x to the first terms, I have a negative 15x plus 6x is a negative 9x. And then 50 minus 30 is a positive 20. So you still do the same exact way, it just adds one additional step at the beginning where you have to take care of these values that are connected to the outside of the parentheses. All right, let's keep going. Let's look at subtracting polynomials. So the same thing as before, the subtraction is the same thing as adding the opposite. And you're going to remove the parentheses from the first expression and rewrite each term. Now, when you remove those parentheses from the second expression, you have to change everything in there. You have to change the sign of everything in the second one. Because technically, if you look at this first example, you are distributing, this is a trinomial minus this trinomial. So really, this is a negative 1 that's attached to that second set of parentheses. So my first set I'm going to rewrite exactly the way that it was. So I still have a 2x to the third plus 4x squared minus 6. But I need to distribute this negative 1 into this second set of parentheses. Negative 1 times the positive 5x to the third is a negative 5x to the third. Negative 1 times a positive 2x to the second is a negative 2x to the second. And then negative 1 times a negative 2 is a positive 2. So all it really did was change the sign of each one of these pieces. Then you go back and combine like terms exactly the same way we have been. Okay? The only difference here is that very first step with the subtraction. You have to distribute that negative through the second set of parentheses. Now you combine like terms like normal. Make sure that you're following standard form. So you're starting with the highest exponent and decreasing as you go. So the same thing here for part B. I am subtracting. I'm taking this trinomial and I am subtracting this trinomial from it. So because I'm subtracting, my first set of parentheses I can just rewrite. My second set, I have to technically distribute that negative to each piece, which all it does is change the sign. So it becomes a negative 3c squared, a positive c, and a negative 1. Then you just combine like terms exactly like normal. Again, going in standard form. Now, switching it up a little bit, just like we did with the addition, if you have values out front of those parentheses, you do need to distribute those in first. So in the same exact way that we distributed before, I'm going to distribute that 5 through the first set of parentheses. So that's going to give me a 10x squared, a negative 15x, and a positive 50. Then I still have to distribute here. Now be careful, this is a negative 3 that you're multiplying in. So negative 3 times the 3x squared is a negative 9x squared. Negative 3 times a positive 2x is a negative 6x. Negative 3 times a negative 10 is a positive 30. So you're really going to have to be careful with your signs when you're distributing that negative. Okay, be extremely careful with your signs. Again, it's going to change the sign of everything originally. Originally this was a positive, it becomes a negative. This was a positive 2x, it becomes a negative 6x. A negative 10 becomes a positive 30. So it still switches signs exactly the same way, but now you're also multiplying it by the 3. And then you're just going to combine like terms exactly like we have been in standard form. So starting with the highest exponent that you have, which in this case is your x squared terms. Okay, and then decreasing from there. Again, this is concept number 8, which is the classifying, adding, and subtracting polynomials.